Hi everyone, I'm Amir Hossein. In this video I show you how to simulate MSG SEVIRI satellite image by considering the radiative effect of dust particles. So in this simulation we use WRF model outputs and WRF outputs for dust particles, and we use RTTOV-14 software to run the RTTOV model. So you know RTTOV-14 software, here is the location of the RTTOV-14 software. You clone it in your local machine and navigate to the WRF data directory. Here I open the name list. The name list is preset. I just show you some necessary information. All the information I have already explained all the information repeatedly in the previous videos, and here I recommend you to check out the previous video about MSG SEVIRI simulation. In this video I just want to show you the effects of the dust particles. So we have a block here that if you enable it, that we do it here, enable it by set it true. In this case the radiative effects of dust particles are included in the simulation, in the RTTOV simulation. And one important point is, if you set it through, you need to specify the path to the coefficient, to a special coefficient which is related to the aerosols. And here, just like the coefficient for gaseous components, for the coefficients, the main coefficient here, for the aerosols you also need to specify the suitable coefficient here, which in this case it is for the MSG2 and the SEVIRI sensor, which we want to simulate an image of that. And all other parameters and directives are exactly the same as previous video. So before that I just disable post-processing and verification, false, and now I run it, Python RTTOV-14. You should activate the correct Python environment. So let's say in the previous Python environment this module was absent, so I activated the correct Python environment. Now again run it. It extracts the input data. You have the input data here in this directory. I don't want to explain it again, but here you can see a new shell script is available. The shell script is a specialized shell script to run RTTOV model considering the radiative effect of dust particles. So I run it here, just like this is actually for WRF Chem, just like the like previous run. You set the arguments G4tran here, run it, and it takes some time because it runs for each grid points of the WRF model. Okay, I just paused the video. Now the simulation, RTTOV simulation for 3844 grid points of atmospheric data from WRF model output is finished, and now you can see the outputs here. Outputs, these are the outputs, and opening one of them you can see the difference of this output from other outputs. you can still see the brightness temperature, but this brightness temperature is different. The values are different from the brightness temperature that was simulated without considering the radiative effect of dust particles. Because the aerosols here are actually considered in the simulation. These aerosols are actually dust particles. Not all aerosols are included, only dust particles here are included. Okay, and I open it and post-process it. I activate or enable the post-processing block, and this is the post-processing suffix, no need to change it. And image plot all bands, set it to true, so you will have images for each post-processing. And the RGB brightness temperature, this is just let it to be disabled. This is not the case here. Save it and run RTTOV-Pi again. Okay, here you have the new directory, post-processing, and okay, the outputs are exactly the same as previous without simulating with the radiative transfer of dust particles. Is exactly the file names are exactly the same, but file contents are different. The previous variable that I showed you, overcast radiance. This overcast radiance does not apply for dust particles. So let me show you some other variable radiance. This is the output, RTTOV output for radiance, and you can see that for the three variables, for the three bands, you have RTTOV simulations for these three bands. And also these are some images. This is for brightness, temperature, emissivity, overcast radiance. There is no output for overcast radiance if the dust particle simulation radiative transfer of dust particles are activated. There is no overcast for dust case. And this is radiance and also transmittance. There is no transmittance for dust radiative transfer. Okay, and let's get back, and now the verification, which is the last block. Set it true. Everything is the same as running RTTOV-Pi without dust radiative transfer. So they are exactly the same, and this is the satellite file, which is skipped because the satellite file group here is activated. So the satellite file directory, this is the directory for satellite data information. So the MSG SEVIRI satellite data information is kept in this directory, and the index number 53. Let me show you again. Satellite sensor index number 53. Number 53, you can see that this is the sensor for Meteosat 8 to 11 SEVIRI data in native format. And the native format, why it should be in the native format? Because if I open the directory of satellite data here, you can see that the satellite data is based on native format. And okay, now if the last directive is keep remapped satellite to WRF data domain. Okay, if you enable it, you will have your observational satellite data mapped on your WRF domain. So you can see that how your satellite data can cover your WRF domain, the WRF geographical domain. I run it. Before that, I change my Python environment, then run it. It runs RTTOV software and compares satellite data with your RTTOV output simulations. The first verification for the first band, second band, and third band. Okay, and NetCDF files are generated. Go to the WRF out verification here, and let me open one of them. You can see that your MSG SEVIRI satellite data is mapped on the WRF geographical domain, but the verification output, if I open the verification output, this is the statistical score for Taylor diagram, CV, RMSE, and correlation. You can see the comparison of the WRF of the RTTOV simulation output with the MSG SEVIRI satellite data. Actually, this comparison is a verification for your WRF model output, because your RTTOV outputs were based on your WRF model output. So this is actually a verification for your WRF model output. Also, I open the Taylor diagram. This is the Taylor diagram, and just let me show you the previous Taylor diagram without dust particles. I have saved it somewhere. Geez, verification, Taylor diagram. This is the, yeah. The left one, the left Taylor diagram was the RTTOV simulation, was the comparison of RTTOV simulation with MSG SEVIRI satellite data without activating, without applying the radiative transfer of dust particles. But the right one is comparing RTTOV output with satellite MSG SEVIRI data by applying the simulation of the radiative transfer of dust particles. So you can see that the difference between these two simulations.